We're taking a look now at question number 2 from the spring final exam. I'm going to do all 3 of them at the same time. You only had to choose one. So the most important thing to do is to make sure that you bring everything over to one side of the equation and get the equation set equal to 0. So I'm going to subtract 7 from both sides of the equation. 18 minus 7 is 11. So my new equation is r squared plus 12r plus 11 equals 0. Now, what we need to do is list the factors of 11 that will add together to give me 12. Well, the nice thing about this one is that 11 is prime, so its only factors are 1 and 11. If we add them together, they're going to give us a positive 12. So we know the factors are r plus 1 and r plus 11, and that has to equal 0. So we use the zero product property, which tells us that anything times 0 is going to be equal to 0. So either this factor is equal to 0 or this factor is equal to 0, so that their product is 0. So when we solve each factor individually, we get that r equals negative 1 and that r equals negative 11. And you could simply leave it this way, or if you wanted to, you could put it in the curly braces, 1 and negative 11. And I should have written them the other way. I should have written it negative 11, comma 1, so that they were in order from least to greatest. But as long as you list them in n order, you're okay. The second one now, we have r squared plus 2r minus 3 equals 4. So I'm going to bring the 4 to the other side. We have r squared plus 2r minus 7 equals 0. Now again, we want to list the factors of 7 that when we subtract them give us 2. Well, 7 is also prime, so its only factors are 1 and 7, and there's no way to get 2 from those factors. So we can use the quadratic formula to solve this. We can solve by completing the square. I'm going to go ahead and use the quadratic formula. So it's on the reference sheet, and you can refer to it there to find it. So we have x equals negative b, and remember the coefficient here is 1, so that's a, b is 2, and c is going to be negative 7. So the formula says negative b plus and minus the square root of b squared, so 2 squared is 4, minus 4 times a, which is 1, times c, which is negative 7. And that's all divided by 2a, so 2 times 1. So when I simplify, I have negative 2 plus and minus the square root of 4. Now I'm going to multiply. 7 times 4 is 28, and we have a negative times a negative, so it's going to be positive. So we have 4 plus 28 all over 2. 28 plus 4 is 32. So we have negative 2 plus and minus the square root of 32 over 2. So we can, this 32 is not a perfect square. So we are going to have 2 factors here, 2 possible solutions. There are going to be 2 roots. We know that there are going to be 2 roots because we're going to have to add and subtract the square root of 32. I can simplify this. 32 we can get by multiplying 2 times 16, and the square root of 16 would be 4. Okay, so we can simplify that to 4 square root of 2. So we have negative 2 plus and minus 4 square root of 2 over 2. If you wanted to reduce it, you can reduce it. Everything here can be divisible by 1. So we would have negative 1 plus or minus 2 root 2. And that's the exact answer. You can find the decimal answers by putting that into the calculator. The last one, we have r squared plus 18r plus 73 equals negative 9. So I'm going to add 9 to both sides of the equation this time. So we have r squared plus 18r plus 82 equals 0. Again, we can use the quadratic formula, which is on your reference sheet. Our a is 1, our b is 18, and our c is 82. So we have x equals negative b plus and minus the square root of b squared minus 4 times a times c all divided by 2a. Okay, so I'm going to simplify. Negative 18 plus and minus. The square root, 18 squared is 324. Here, this is going to be negative. Negative 4 times 82 gives us negative 328. And that's all divided by 2. So what I'm noticing here is this is smaller than this, so underneath the radical, I'm going to have a negative value. So here, there is no solution, okay, because we cannot take the square root of a negative number in the real number system.